Hi friends. See, in yesterday's class we discussed about in part 2, I think in ray optics part 2 we are discussing about mirror formula. Okay, in part 2. Now in part 3 of ray optics, in part, because I told you it's a very big chapter. Okay, in part 3 we'll discuss about the mirror formula, that is 1 by f is equal to 1 by v plus 1 by u. See, because it is mainly oriented regarding m set, I am not deriving these equations. Okay, by using simple geometry you can derive 1 by f is equal to 1 by v plus 1 by u, whether if you take convex mirror or concave mirror. Okay, so because mainly it is oriented for m set and neat, so that's why I am not using the derivations here. Derivations you can easily derive. Now this is the mirror formula, either for concave or convex. Even if you take concave mirror or convex mirror. I told you yesterday about the concave and convex mirror. Concave mirrors are generally used by the doctors, dental doctors, to observe the things, and convex I told you in super bazaar, supermarkets, to observe the theft, and also in the vehicles it will be used for the backside vehicles, whether it is coming or not, for the observing. So in mirror formula, if you observe 1 by f, that is f is focal length, v I told you yesterday only, image distance always measured from the pole, and u is the object distance which is always measured from the pole. Okay. Now according to the mirror, if it is concave or convex, yesterday I told you for concave mirror focal length is negative, and for convex mirror focal length is positive. So this is all I told you why and when. Okay. Now in today's class we will do one thing. We will take a small numerical and we will try to solve the characteristics of the images where it is formed in concave and convex parallelly. I will take a small example, that is, for example, see here, the focal length I am taking 12 centimeters for a concave mirror, and the object distance I am taking 30 centimeters. I will draw the figure. We will try to solve a small numerical, because in the examination this is coming. Because of concave mirror gisanu. This is a concave mirror. Focal length is given as 12 centimeters, and we know for concave f is negative, that is minus 12 cm, and this is pole, and this is the imaginary line, that is principal axis, pole of the mirror, and object distance is given as, say for example, 30 centimeters. Object, that means object is placed. What is r here? R is equal to 2f kada? R is equal to 2f, and then the 2 times focal length, that means this radius, that is center of curvature. For example, it is r here. This r is nothing but 2 times of f. For example, focal length 12 kabatti 25 cm. R is also negative in this case, I told you in part 2. Now for this the focal length or focus, focal length enta nanu 12, all measured from the pole. Now the question is asking you, he has given focal length, object distance, and is asking you to find the characteristics, what type of image is found for this case, for concave. So ఇలాంటి సందర్భం మనం ఏం చేయాలి, మన ఇమేజ్ డిస్టెన్స్ కావాలి. So we know the focal length 1 by f is equal to 1 by v plus 1 by u for mirrors. So from this what is v? If you take LCM, uf by u minus f, shortcut, because if you take LCM, చూడండి ఇక్కడ నుంచి 1 by f minus 1 by u is equal to 1 by v కదా. ఇందులో LCM కట్టండి. LCM కడితే ఎంత అవుతుంది? uf u minus f. So from this 1 by v. So this is the shortcut formula. We want to be reciprocal, uf by u minus f. Now I will substitute here and I will try to find out the image distance where it is from. What is u? Measured from the pole. And the distance from 30 centimeters. That means minus 30 into f focal length minus 12 by u minus f. Minus 30 minus f minus 12. So that is top pi, 12 3 is 36, 360 plus, and minus into minus plus covered minus 30 plus 12. So this is 360 by around 18. Just చూసుకోండి. 10 minus 2, 8, 2 minus 1. And this is down minus. So finally minus 18 2s are. Okay? 2 8 is 16, 1 to 3. So minus 20 centimeters. Clear? So నాకు image ఎక్కడ form అయింది? Minus. అంటే from the pole. So from the pole minus 20. This is already center is 24 అంటే around like here. So image is formed here. For example, say like that, minus 20 from the pole. So image ekkada form ayindi? 20 centimeters from the pole. Clear? So this is how you have to take. Adotha meeku, for example, if I take some extended object ekkada teeskondi meeru. You can take anywhere object. Object anta 30 centimeters annam kada. So 30 and for example, this is 24. Somewhere over here. Object AB. First light going parallel, goes through focus, reflected light. Okay. Second one you can take somewhere over from pole. Okay. Second one you can take somewhere over from pole. Pole ni తీసుకుంటే మనకి ఏమవుతుంది? ఇక్కడ నుంచి pole ఇక్కడ అడ్జస్ట్మెంట్ మనకి ఇమేజ్ ఇక్కడ ఫామ్ అవ్వాలి చూసుకోండి. సో ఇట్ అడ్జస్ట్ ద థింగ్. ఒకవేళ ఫోకస్ నుంచి తీసుకుంటే parallel. I'll take from focus better. I'll take from focus. తీసుకున్నట్టు అయితే ఫోకస్ నుంచి లైట్ రే ఎలా ఉంటుంది? ప్యారలల్గా వెళ్తుంది. సో ప్యారలల్ see here. So image is formed here. A dash, B dash. So ఇక్కడ for this problem the image is what? Real, inverted and of course little diminished. Little diminished. కొంచెం సైజ్ తగ్గింది, diminished. Clear? So this is how you have to get the problem. In the case of concave. ఇక్కడ మీకు magnification కూడా వస్తుంది. Height of the image by height of the object is equal to magnification and that is equal to minus V by U. You can also calculate magnification. ఎంత వస్తుంది? M is equal to height of the image ఇవ్వలేదు కాబట్టి, ఆబ్జెక్ట్ ఇవ్వలేదు కాబట్టి V తెలుసు. Minus V. What is V value got? ఎంత వచ్చింది మనకి? 20 centimeters. That means with sign. Okay. Minus V value minus 20 by U minus 30. Okay. Minus cancel, 0 cancel, that is equal to minus 2 by 3. ఎంత అవుతుంది వాల్యూ? Around minus 0.66 centimeters. So here you can see the magnification value is negative. Magnification ఏమైంది? Negative value. M is equal to negative minus 0.6. Okay. Minus 0.6 value. So like this you can even calculate the magnification value. Okay. So this is for what? Concave mirror. Let us try for convex mirror. Okay, we will speed up now. Let us try for the next one, that is convex mirror. Clear? Now same thing, suppose if you go for Hi friends, so sorry for the disturbance, just now the power cut is there. So let us continue the class now. Now just now seen about the concave mirror problem. Now let us see for the convex mirror. See, in convex mirror, if you observe carefully, the structure will be in this fashion. This is convex mirror. Here the focal length is given as around 15. Focal length is given around how much value? 15 cm. Focal length is given as 15 cm. This is the pole. Okay. In this case, we will observe what happened. This is the principal axis. Okay. And here also I will take the object distance as around 30 cm. Because you can see for here the center of curvature will be in this side. Okay. And we know for convex it is positive. Focal length is also positive because in this along the direction of the light. So object distance is given as 30 cm from the pole, and now he is asking you where the image is formed. Once again we will apply the same mirror formula, 1 by v plus 1 by u, or v is equal to uf by u minus f. So when you apply, the image distance you will be getting as uf, that is minus 30 into minus f. Okay, here f is focal length plus, okay, f kada, it's a positive, uf by u minus f, u minus f. So on the top it is minus 450, down it is minus 45, you can see, minus 45. Minus get cancelled, 445 tens. So here I got plus 10 cm. Image ekkada naku, you can see positive, that means that is back side of the mirror, not in front, here, somewhere over here. 10 cm means, what is the focal length? R is equal to 2f. R is equal to 2 into 15, that is 30 centimeters the R. So this is 30 centimeters. So focal length is around 15. I got it 10, and around I got it here, image. I got image here. Clear? So image, suppose if you take any extended object, for example say, extended object A, B. Okay? Then what happens? Parallel light ray, and this is the normal. This is the normal drawn, incident angle, this is the reflected angle, it goes like this. Okay, when you extend, it will come over here like this. If you take one more line, okay, again normal, okay, if you extend somewhere it will meet here. So if you observe carefully here, the image is virtual because back side of the mirror. I told you in convex mirror always the image will be back side, that is virtual, upright and little diminished, So I told you whenever the image is virtual and upright, what is magnification? Both sides, same side. So magnification is positive, that is height of the image by the height of the object is equal to minus v by u, and this is m. That means magnification ఏమవుతుంది, రెండు ఒకే వైపు ఫామ్ అయింది, height of the image by height of the object, both sides. So m is positive here. Okay, so height of the image means little lesser, height of the object is little more, so this is equal to m. You can also calculate the value if you want it. You can calculate, because HA by H is equal to minus V. What is the V value got? 10 centimeters. So 10 centimeters by U minus 30. With the sign I told you. Okay, 0 cancel. Minus into minus plus. చూడండి, plus 1 by 3 centimeter. That is how much? 0.33 centimeters. That means height of the image is equal to 0.33 into H0. Okay, so here you are getting height of the image is little lesser value, 0.33 into this thing, height of the object. So like this you can picturize the values. Okay, you can calculate the values for concave and convex mirrors by using these formulas, and you can characterize whether the image is real, virtual, upright, magnification is positive or negative. So these are the cases you have to observe in concave and convex mirrors, please. So please try to solve the problems by learning the concept. Light is a very big concept. You have to learn the subject first of all. Without knowing the concept, you cannot go forward in light chapter. Okay. Now let us go still further in this chapter. That is, I told in the before class, magnification is formula. Part 2 lo meeku magnification formula for mirrors, M I told you is minus V by U. Height of the object by height of the image by height of the object. We will see how this minus V by U has come. I will take concave mirror. Now for example, if I take concave mirror, okay, this is the principal axis, this is the pole, principal axis, concave mirror. I'll take somewhere, this is the center of curvature, center, okay, and of course this is the focus and this is focal length accordingly. Now we have to show that m is equal to minus v by u. Image distance by object is minus. So for that what I'll do, I'll take some object over here, point object, sorry, extended object AB. I'll take two lines, as I told you, to form image. Two light rays are important. One is going parallel and coming back with the focus. Second one, what I'll do, I'll take through pole. I told in the properties of the part 1, when light is going through pole, making some angle, it again reflects to the same angle. Loss of reflection. So here you can see both the light rays are meeting over here. So the image is what? A dash, B dash. Now observe carefully, ABP, comma, A dash, P are similar triangles. When both are similar, you can apply the rules. Opposite by adjacent is equal to opposite. This is height of the object and this is the height of the image. So from this, what is tan theta? In triangle ABP, what is tan theta? Opposite by adjacent. Opposite with the sign. So opposite, this is above the principal axis, positive. By adjacent means what? Object distance taken from the pole. So that is nothing but minus u. Equation 1. Again calculate tan theta because both are having same angles. Tan theta in the triangle P A dash B dash. In the triangle P A dash B dash lo tan theta enta avutundi. Again opposite ante ikkada enta below the principal axis, that is negative value. That is minus hi by adjacent. Adjacent means what? Image distance. Image distance what? V. Always measured from the pole. So minus V. Equation 2. So tan theta, equation 1 and equation 2 both are representing angle. So therefore I can equate as HO by minus U is equal to minus minus, I can cancel here, HI by V. Or I can write this equation as HI by HO, height of the image by height of the object, is equal to V by U minus, you can observe here, H0 V0, H0 V, H0 V, okay, UHI, minus is there as usual. So, but actually what is this one? Height of the image by height of the object and M, and that is equal to what? Minus V by U. Therefore, in mirrors, the magnification formula, because it is a linear magnification, okay? So the mirror formula, magnification in mirrors is taken as minus V by U, where V is image distance taken from always pole and U is object distance taken always from the pole. So this is how you can derive for the magnification, okay, for mirrors. Now let us go to the next item. Very, very important. See, these derivations are important for the numericals also. So whenever the derivations are required, I am deriving, because mainly we are concentrating on MSET and NEET. So therefore, derivations maximum I am avoiding, but in rare cases I am deriving for you, for understanding in a better manner. Now after deriving the magnification, let us go to the next thing, okay, that is very, very important, okay, that is, shall we do one more problem regarding any height? Okay, we will do one thing. In next conditions, we will go for numericals. Okay, na? Now what I will do is, I will go for the next concept in this one, that is combination of mirrors. Very, very important. Next version. Enter the combination of mirrors. Very, very important in the examination MSET or NEET. That means how many such conditions are there for combination? First one, I will take a plain mirror followed by a concave mirror. Second one, I'll take a concave mirror followed by a convex. A concave and a convex mirror. Second one, a concave mirror and a convex mirror. Third one, okay. Third one, what I'll do, I'll take a different case. I'll take a different case. అదేంటంటే లిటిల్ డిఫరెంట్. అదేంటంటే ఒకసారి ఐ విల్ షో విత్ ద డయాగ్రామ్. కాన్కేవ్, ఓకే, కాన్కేవ్ మిర్రర్ and of course convex mirror, both are not lying in the same pole. Both are not lying in the same pole. I'll show you while explaining. ఈ రెండు కూడా యాక్సెస్ ఒకలాగా లేదు, చిన్న డిఫరెన్స్ ఉంది. సో అది మనం ఎక్స్ప్లెయిన్ చేసినప్పుడు చెప్తాను. ఫస్ట్ మనం ప్లెయిన్ మిర్రర్, కాన్కేవ్ మిర్రర్ చూద్దాం, ఓకేనా? Let us see the first condition, plane mirror and concave. For example, if I take a plane mirror like this, this is a plane mirror, combination of mirrors kada idi. This is a plane mirror, okay, this is the, of course, axis, horizontal axis or whatever, principal axis. For this one, I'll add one more, that is concave mirror. This is concave mirror. This is what? Concave mirror. Now see, both the poles are almost same axis here. Poles both are lying in same axis. So ఇందులో క్వశ్చన్స్ ఎలా రావచ్చు కాంబినేషన్లో? సపోజ్ ఆబ్జెక్ట్ మే బి సమ్వేర్ ఓవర్ హియర్. Object may be somewhere over here like this. For example, like say 25 centimeters from the pole of the concave, and from this around say like 10 centimeters from the pole of the mirror of the plane mirror. Plane mirror నుంచి 10 centimeters, ఇక్కడ concave నుంచి 25 లేదా 30, any value, rough value can take. And you will be giving the focal length of the mirror. Focal length. And we know for focal length of concave mirror it is negative. Focal length will be given. And here also the focal length will be given. But here plane mirror में जा చూసినట్టుగైతే, if you apply the formula 1 by f is equal to 1 by v plus 1 by u. For a plane mirror, what is the radius? Infinity. Radius ఏంటి? Infinity. అర్థం మీకు? R is, because it's straight line కదా, so R is taken as infinity. But what is R? R is equal to 2f. R is equal to 2f. Or R by 2 is equal to f. సో ఫోకల్ లెంత్ కూడా దీన్ని ఇన్ఫినిటీ అవుతుంది ప్లేన్ మిర్రర్కి. అర్థమవుతుంది మీకు? బికాస్ స్ట్రైట్ లైన్ కాబట్టి దీనికి జనరల్గా మనం రేడియస్ ఆఫ్ కర్వేచర్ తీసుకోం, ఇన్ఫినిటీగా తీసుకుంటాం. ఇన్ఫినిటీ అయినప్పుడు ఏముంది? ఆర్ ఈజ్ ఈక్వల్ టు ఎఫ్, ఇక్కడ ఆర్ బై 2 ఈజ్ ఈక్వల్ టు ఎఫ్. సో ఎఫ్ కూడా ఇన్ఫినిటీ అవుతుంది. ఇన్ఫినిటీ బై 2 అగైన్ ఇన్ఫినిటీ ఉంది. సో దీనికి మనకు వద్దు వాల్యూ, ఫోకల్ లెంత్ ఇన్ఫినిటీ వాల్యూ కాబట్టి, ఓకేనా? నౌ ఇలాంటి కండిషన్లో వాడు ఏమడుగుతాడంటే, ఇది సపోజ్ మిర్రర్ 1, ఇది మిర్రర్ 2 అనుకుందాం. ఫస్ట్ రిఫ్లెక్షన్ ఈజ్ మేడ్ బై ఈ మిర్రర్ అంటాడు, మేడ్ బై కాన్కేవ్. వాట్ ఈస్ ద ఫైనల్ ఇమేజ్? వాట్ ఈస్ ద ఫైనల్ ఇమేజ్ ఆఫ్టర్ 2 రిఫ్లెక్షన్స్? ఇలాంటి క్వశ్చన్స్ వస్తాయి ఎగ్జామ్స్లో. వాట్ ఈస్ ద ఫైనల్ ఇమేజ్ ఆఫ్టర్ 2 రిఫ్లెక్షన్స్ ఇఫ్ ఫస్ట్ రిఫ్లెక్షన్ ఈజ్ మేడ్ బై కాన్కేవ్ అంటాడు. అప్పుడు మీరేంటే నార్మల్గా సింపుల్ ఫార్ములా యూజ్ చేస్తారు. ఆబ్జెక్ట్ తీసుకుంటారు, ఆబ్జెక్ట్ నుంచి లైట్ రేస్ వెళ్తుంది, ఓకే, అండ్ యూ నో ఇట్ విల్ బి రిఫ్లెక్టెడ్ అగైన్. అలాగే మరో లైట్ రేస్ అగైన్ రిఫ్లెక్టెడ్, ఓకే, ఇట్ కమ్స్ బ్యాక్ లైక్ దిస్. సో ఈ ఫస్ట్ రిఫ్లెక్షన్ ముందు దీని ఇమేజ్ కడతారు బై యూజింగ్ యువర్ ఫార్ములా వి యూఎఫ్ బై యూ. ఐఎమ్ నాట్ గివింగ్ ఎనీ వాల్యూస్, రఫ్ క్యాల్కులేషన్ టెలింగ్. సో ఇమేజ్ కడతారు. You see image what you are getting, that value. Generally for concave mirror మీకు image ఇటువైపు వస్తుంది, that is negative value. Suppose somewhere you want over here, for example ఇదంతా 25 plus 10 35, okay, for example say plus 40 అంటే v is equal to suppose say minus 47 వచ్చింది అనుకోండి. assume that V is equal to minus 40. And ఏంటి from the pole 25 plus 10 ఎంత 35 అంటే ఇక్కడ ఎక్కడ వచ్చింది అనుకుందాం. Let us assume the image is formed here, because image is always calculated from the pole, from the first mirror. Now we will be asking what is the final image అన్నాడు after 2 reflections. So first reflection ఇక్కడ, next మళ్ళీ ఇక్కడికి వస్తుంది కదా. Okay, if you draw the ray diagram, reflection అవుతుంది కదా పైకి. ఓకే, బికాజ్ ఒకవేళ ఇది తీసుకుంటే వెళ్తుంది రిఫ్లెక్షన్. నార్మల్ గీస్తే ఇక్కడికి మళ్ళీ ఇది కిందకి వస్తుంది కదా. ఇక్కడ నార్మల్ గీస్తే ఈ విధంగా. సో ఇక్కడ ఫైనల్ ఇమేజ్ ఉంటుంది ఐ డాష్. కానీ ఇఫ్ యూ అబ్జర్వ్ కేర్ఫుల్లీ, దిస్ ఇస్ ఎ ప్లేన్ మిర్రర్. ప్లేన్ మిర్రర్ ఏంటి, దిస్ బికమ్స్ ఫర్ వాట్, వర్చువల్ ఆబ్జెక్ట్ అయిపోతుంది దీనికి. మిర్రర్కి వాట్ ఎవర్ ఇమేజ్ ఫార్మ్డ్ బై ద కాన్కేవ్ బికమ్స్ వర్చువల్ ఆబ్జెక్ట్ ఫర్ దిస్ వన్. సో ఇమేజ్ ఇక్కడ ఫామ్ అవుతుంది. ఇక్కడ అంటే ఎంత, ఇన్ ప్లేన్ మిర్రర్ ఆబ్జెక్ట్ డిస్టెన్స్ ఇస్ ఈక్వల్ టు ఇమేజ్ డిస్టెన్స్. ప్రాపర్టీస్, ఆబ్జెక్ట్ డిస్టెన్స్ ఇస్ ఈక్వల్ టు ఇమేజ్. దేర్ఫోర్ ఇది 5 centimeters కాబట్టి ఇది కూడా యూ విల్ బి హ్యావింగ్ 5 centimeters. రఫ్ క్యాల్కులేషన్ ఐమ్ టెలింగ్ యూ. సో ద ఫైనల్ ఇమేజ్ విల్ బి రైట్ సైడ్ ఆఫ్ ద ప్లేన్ మిర్రర్ at 5 centimeters. So this is how you have to calculate in the combination of mirrors for in the case of plane and concave. Let us go to the next one. See, I have not taken any values. I am explaining because lack of time. Okay, just rough values I have taken. I am telling you how the image is formed, in what fashion. Second condition చూడండి, combination. ఇక్కడ ఏంటి, concave and convex. Here also both are in same plane. చూడండి. నెక్స్ట్ కండిషన్ ఇక్కడ రాస్తున్నాను. సెకండ్ వన్ ఏంటి, కాన్కేవ్ మిర్రర్ కామా కాన్వెక్స్ మిర్రర్. సెకండ్ వన్. సో జాగ్రత్త చూడండి, ఐ విల్ టేక్ లైక్ దిస్ నౌ. సో దిస్ ఈస్ ద మిర్రర్ 1 or mirror 2, what is the concave. You can see the concave surface like this, and this is the imaginary line. Okay, and this is the pole for this mirror. Now here one more mirror is kept. Adentadi convex. చూడండి, convex అంటే ఏమవుతుంది, bulging side this side. So here the polished surface. This is convex. Now you will be telling some object is placed at some distance. Okay, somewhere over here object. Okay, and you will be giving the distance also from this mirror and also from this mirror. Okay, let's say some 20 cm. Rough values I am telling. Let's say 30 cm. Okay, now you know, as you know, the rays will go and hit. And for this one, where is center? See here, F is positive because it is what? Convex mirror. Focus ikkada enta untundi దీనికి F, and this is the focal length, of course. So if you draw normal for this one, this is the incident angle. It may be reflected. It goes like this. Okay. In the same way, one more if you take, again normal, reflected, it goes like this. Okay. Now these light rays, after reflection, first reflection from this mirror, if this is mirror 1, this is mirror 2, this is the first reflection from this one. Again it meets what here? Concave. So light is coming in this incident light now. Now incident light is coming like this. From which mirror? Convex mirror. So light is coming this fashion. Now what will be the final image? Again, what happens here? So for this concave, what is object distance? Whatever image you got from this formula is here. V is equal to UF by U minus F value. Whatever, because of course for convex what you will get virtual somewhere over here. So this image will become virtual object for this one again. And what will be the distance? 30 plus 20 plus whatever this value got. The total distance you have to take here. Object distance. And again you have to calculate for V for this one. UF by U minus F. See, I am not giving any values for time factor. I am explaining how the combination of mirror takes place. Plane versus concave, concave versus convex. Okay, you can in your book you will be having so many numericals. You can take the values and you can put, and finally you can calculate. So ఇక్కడ పడింది ఏమవుతుంది దీని మీద, ఇది ఏం చేస్తుంది, రిఫ్లెక్ట్ చేస్తుంది మళ్ళీ చూడండి. Okay, it will try to reflect somewhere over here like this, and this will be the final image I dash. So final image ఎక్కడ వస్తుంది మనకి, ఓకే, ఫ్రమ్ ద పోల్. మీకు తెలుసు కదా కాన్కేవ్ కి maximum నెగటివ్ వాల్యూ వస్తుంది. సో దిస్ ఇస్ ద ఫైనల్, అంటే ఫైనల్ ఈస్ రైట్ సైడ్ ఆఫ్ ద సెకండ్ మిర్రర్, రైట్ సైడ్ ఆఫ్ ద second mirror. So like this you can calculate for this type of problem. Now last problem, if the pole is not on the same axis, అప్పుడు ఏం చేయాలి చూద్దాం. చూడండి, sometimes pole ఒకే యాక్సిస్ మీద ఉండదు, అప్పుడు ఏం చేయాలో చూద్దాం. In combination of mirrors, sometimes what happens is the pole will not be lying. For example, see this case, again concave and convex, again concave and convex mirror low. Observe carefully. Here I am having a third one, that is third case. This is concave with some focal length. Now this is the pole here for this one, and this is the horizontal axis. Clear? Now exactly, see here, exactly from the center of this one another mirror is placed. Okay na? Another is convex mirror placed. Convex. Please watch carefully. This is convex mirror. Inside it is polished. Now you observe the pole of this one is beneath. Okay na? The pole is beneath. Here the pole. You can see this pole is at some height. So that height also sometimes will be giving like 2 centimeters or millimeters or whatever thing. Sometimes it may be 3 millimeters or 2 millimeters. So ఈ పోలు దీనికన్నా ఎలా ఉంది, 2 millimeters లేదా 3 millimeters పైకి ఉంది, ఎత్తులో ఉంది, and it is below. Okay, you can see 2 millimeters or 3 millimeters. Now in such cases sometimes you will be giving this is the first mirror, this is the first mirror అనుకోండి. Let us assume this is the first mirror M1 convex, అలాగే ఇది second mirror, and you will be giving the object also somewhere over like this object, okay, beneath, or even you can take on the top also object, extent of, you will be giving the height also, height of the object like 1 mm or 2 mm. Okay, sometimes you will be giving this object height also 1 mm or 2 mm. Okay, so in such cases ఏం చేస్తారు, ఇలాంటప్పుడు ఏం చేస్తారు మీరు, సేమ్ థింగ్ అండి, మళ్ళీ యాజ్ యూజువల్ ఫైండ్ ద ఇమేజ్ డిస్టెన్స్. V is equal to UF by U minus F. Find the image where you are getting, whether this side or that side. Suppose maximum I told you for convex, always it is be virtual, because this is the right side, this is the center, this is the focus. Suppose somewhere you have got like this here image. ఆ ఇమేజ్ మీకు రైట్ సైడ్ వస్తుంది, వాల్యూ వస్తుంది మీకు, యూ విల్ బి గెటింగ్ సమ్ వాల్యూ యాజ్ ప్లస్ వాల్యూ. ఒకవేళ ప్లస్ వచ్చింది అనుకోండి పైకి, if you got plus value the image, you have to draw like this, you have to draw like this image. And how to get the height of the image, please? How to get height of the image? We know hi by ho is equal to m, that is equal to minus v by u. You have to use this formula. So height of the image ఎలా వస్తుంది, height of the image by height of the object already ఇచ్చాడు కిందకి, negative sign. For example, I am telling you minus 1 mm is equal to minus of v. V already మీకు వచ్చే ఉంటుంది. For example, say like around 10 centimeters అనుకోండి, అందరికి 10 centimeters, ఓకేనా, like 10 centimeters by u. Object distance for example మీకు ఒక 20 centimeters అనుకోండి, Okay, object distance in the minus 20 centimeter. V plus in this one because right side వచ్చింది. So ఇప్పుడు ఏముంది సెంటీమీటర్ సెంటీమీటర్ 0 0 ఈ మైనస్ ఇంటూ మైనస్ ప్లస్. సో ప్లస్ ఎంత వచ్చింది మనకి ప్లస్ హాఫ్, కానీ ఇక్కడ మళ్ళీ మైనస్ ఉంది. సో హెచ్ఐ ఈజ్ ఈక్వల్ టు మైనస్ హాఫ్ ఎంఎం. అంటే ఇమేజ్ కిందకి వచ్చింది మళ్ళీ. మైనస్ వాల్యూ మీన్స్ వాట్? హైట్ ఈస్ డౌన్, ఇట్ ఈస్ కమింగ్ డౌన్. ఓకే, సో లైక్ దిస్ మైనస్ అంటే దీంట్లో సగం, సమ్వేర్ ఓవర్ లైక్ దిస్ మైనస్ హాఫ్ ఎంఎం. ఎంత వచ్చింది హైట్ మీకు? మైనస్ హాఫ్ ఎంఎం. సో లైక్ దిస్ యూ హ్యావ్ టు బి వెరీ కేర్ఫుల్ వైల్ డూయింగ్ ద కాంబినేషన్ ఆఫ్ మిర్రర్స్. మీకు అర్థమవుతుందా? అర్థమవుతుందా మీకు? See, when you're calculating here, you got the value as how much? Height of the image by height of the object is equal to minus of v by u. సో హైట్ ఆఫ్ ద ఆబ్జెక్ట్ మీరు తీసుకున్నప్పుడు చాలా జాగ్రత్త చేయాలి విత్ రెఫరెన్స్ ఇది. అలాగే ఇక్కడ చేస్తున్నప్పుడు కూడా యూ హ్యావ్ టు బి వెరీ కేర్ఫుల్. ఫైనల్ రిఫ్లెక్షన్లో సేమ్ థింగ్. వెన్ యూర్ క్యాల్కులేటింగ్ హియర్ ద హైట్ ఆఫ్ ద ఆబ్జెక్ట్, దెన్ యూ హ్యావ్ టు క్యాల్కులేట్ విత్ రెఫరెన్స్ టు దిస్ పోల్. అంటే దిస్ వాల్యూ షుడ్ బి యాడెడ్ టు దిస్ వాల్యూ. So be careful while doing such problems. Clear? Right. Now let us go to the next one. After combination of mirrors, let us go to the next case, that is velocity in spherical mirrors. Very very important. Velocity in spherical mirrors. Very very important. ఇందులో మీకు 4 cases ఉన్నాయి, 4 cases. All those I'll be telling you. Case 1, concave mirror. Okay, focal length will be given, pole, object distance will be given. And here object will be moving parallel to axis. For example, some velocity 2 meters per second. Object will be moving parallel. First one is parallel to the principal axis. First case. Second case. Okay. Second case, pole, concave mirror. Now here object distance will be given. Here object is moving perpendicular to the principal axis. Say some 3 meters per second or 3 centimeters per second. Okay, ikkada perpendicular to the principal axis. Second case, perpendicular to PA, principal axis. Okay, third case, same concave mirror, pole, object distance is given. Now object is moving with some angle theta. Okay, around like 2 meters per second, and it will be moving horizontally, x direction, and also y direction. This is the third case. Last case, object is not on the principal axis, above the principal axis. Here is the object and he is moving parallel around 2 meters per second. These are the 4 cases you have to deal regarding velocity of the spherical mirrors. Modernది ఏంటి? Object is moving parallel to principal axis around say 2 meters per second or 2 centimeters per second. Object distance will be given. Second case, perpendicular to the principal axis. Third case, moving at some angle. And fourth and last case, moving at a height on the principal axis towards the mirror. So one by one I'll try to explain for you. We'll see how to do such type of problems in examination. First of all, let us see the first case. ఫస్ట్ కేస్ చూద్దాం మనం. ఫస్ట్ కేస్ ఏంటి? ఇక్కడ చూడండి, ఆబ్జెక్ట్ ఈజ్ మూవింగ్ విత్ సమ్ వెలాసిటీ సమ్ 2 సెంటీమీటర్స్ పర్ సెకండ్. అంటే అర్థం ఏంటి? ఇక్కడ ఆబ్జెక్ట్ డిస్టెన్స్ ఇస్తాడు. ఓకే, అండ్ ఆబ్జెక్ట్ ఈజ్ మూవింగ్ టువర్డ్స్ ద మిర్రర్. ఓకేనా? సో వెన్ ఆబ్జెక్ట్ ఈజ్ మూవింగ్, వాట్ ఈజ్ చేంజింగ్ హియర్? U changes. When U is changing object, image distance also changes. So V changes, u చేంజ్ అవుతుంది కాబట్టి v కూడా చేంజ్ అవుతుంది. సో వాట్ హ్యాపెన్స్ హియర్ దెన్ we have what is the formula 1 by f mirror formula is equal to 1 by v plus 1 by u. So when u and v are changing, how to use the formula here? I can use this one as f to the power of minus 1, v to the power of minus 1, u to the power of minus 1. Okay? Now I will try to find the derivative of this one with respect to time. Derivative of this one, differentiating above equation with respect to t, time. So this is constant focal length కాబట్టి 0. Focal length 0. Try to derivate this one, n into x power n minus 1. Okay? And with respect to time. So n into x power n minus 1 into dv by dt. Because with respect to time we have to derivate. Because u and v is changing. Alage plus n into x power n minus 1 into du by dt. Clear? Now I will try to expand this one. 0 is equal to ఇది minus 1. ఇది v power minus 2 కిందకు వచ్చేస్తుంది. That is, I will write it as v square dv by dt. ఇది ప్లస్ ఆఫ్ కోర్స్ ఇది ఎక్కడ పైన ప్లస్ ఇంటూ మైనస్ మైనస్ కదా, ప్లస్ ఇంటూ మైనస్ మైనస్ రాసేద్దాం, మైనస్ ఉంది కదా. సో ఐ రైట్ ప్లస్ ఇంటూ మైనస్ మైనస్ కిందకి 1 by u square into du by dt. Now what I'll do, this one I'll take to this side and this to other side. అప్పుడు ఏమవుతుంది, ఇటు పక్క తీసుకొచ్చేస్తే dv by dt, okay, that is 1 by v square, minus is there, and this take to that side, du by dt into 1 by u square. Observe carefully this equation. What is dv by dt? Rate of change of image velocity. What is v? Image distance. V and image distance. So rate of change of image velocity, I can write as v I vector velocity of the image. Are you following here? Velocity of the image. And please make a note, all these are in x direction I am taking. In x direction. Why? Because the object is moving parallel to principal axis. So x direction lo velocity of the image, I can write as dv by dt velocity of image. Idanta minus 1 by v square is equal to du by dt velocity of the object in velocity of the object in x direction, du by dt. So VO vector, okay, velocity of the object and 1 by u square. Are you following the points here? du by dt and ఏంటి ఇక్కడ velocity of the object in x direction movement, ఇది velocity of the image in x direction. Okay na? So finally I can change this equation as in this fashion. ఎలా రాయొచ్చు ఇది ఒకసారి చూడండి. vi is equal to, I'll take this one to that side, that is v square by u square minus into vo vector. Please observe carefully. Velocity of the image I have taken to the top here. So v square by u square, v square by minus కూడా ఇక్కడ తీసుకొచ్చాను. So minus v square by u square into v0. This is the exact formula. ఏంటిది? When object is moving along x direction. So velocity of the image in x direction is given by minus of v square by u square into velocity of the object. Vector కాబట్టి పైన బార్ పెట్టాను, object in x direction. Please make a note, all these are with respect to what? Mirror. ఇవన్నీ ఏంటి? With respect to mirror, please. So that formula goes finally like this. ఇవన్నీ కూడా ఏంటి? With respect to mirror. All these are with respect to mirror. So with respect to mirror రాయించేది vi with respect to mirror is equal to minus v square by u square vo with respect to mirror, of course vector. So ఎలా రాయించేది from kinematics equation relative velocity vi minus Vm. Velocity of image minus velocity of the mirror is equal to minus V square by U square. Again, VO minus Vm vector. Now, observe carefully. If the mirror is at rest, if this mirror is at rest, then what happens to the mirror velocity? 0. Then what happens? This value goes 0. 0 అయిపోతుంది అప్పుడు ఆ ఫార్ములా మిగిలింది ఏంటి? అది మిగులుతుంది. సో velocity of the image in x direction is equal to minus u square by v square into velocity of the object. If mirror is also moving, okay, along with the object, then you know the directions. This is positive and this direction is negative. Clear? So this is the first case you have to adopt in such cases. If mirror is at rest, this is the formula. Okay? If mirror is moving, positive, negative, you can apply here. And thereby you can calculate the velocity of the image. Clear? Okay. Now I'll go to the next one. Second case. Second case, please. Okay. Now I think I can rub this one. Okay. These are very, very important and regarding examination, numericals. Second case ఏం చెప్పాను? Case 2. Case 2 లో concave mirror ఉంది. Pole is there. But here what happens? Object is there. Object distance ఉంది. It is moving like this, in this fashion. Perpendicular. Second case ఏంటి? Perpendicular to the principal axis. ఆబ్జెక్ట్ ఈజ్ మూవింగ్, పైకి వెళ్తుంది ఇలా గ్రాడ్యువల్గా. ఓకే, సో గ్రాడ్యువల్ ఏమవుతుంది? పైకి వెళ్తుందంటే ఇది చేంజ్ అవ్వట్లేదు. ఆబ్జెక్ట్ డిస్టెన్స్ ఇస్ కాన్స్టెంట్. ఆబ్జెక్ట్ డిస్టెన్స్ కాన్స్టెంట్ అంటే ఇమేజ్ కూడా కాన్స్టెంటే కదా. when that object distance is not changing, image distance is also not changing, only it is going in this fashion, perpendicular. So what is changing now in this case? Object constant, distance, so image is constant. What is changing? See here. Height of the object, height of the image is changing. See, it is moving from here like this. 2 meters per second. Second no 2 meters. Next 2 meters per second. 2 meters per second. 2 meters. So gradually what happens? Height of the object is increasing. Height of the object increases, then the image would increase. So these two will be changing now. Now what happens? See, can you apply this formula now here? Can you apply this formula? Vi is equal to minus v square by u square into v0. Is apply cheyagalaru meeru? Let us see here. Ikkada height of the object, height of the image change avutundi kabatti what is magnification? Height of the image by height of the object is equal to magnification, and that is equal to minus v by u. కానీ ఇక్కడ ఏమంటున్నాను? u and v are constant. uv constant మారట్లేదు, ఎందుకంటే పైకి వెళ్తుంది కనుక. సో ఇఫ్ దిస్ ఈస్ కాన్స్టెంట్, వాట్ హ్యాపెన్స్? హైట్ ఆఫ్ ద ఆబ్జెక్ట్ ఈజ్ ఈక్వల్ టు minus v by u into h0. Since this is constant, find the derivative of this function with respect to time. So dhi by dt is equal to, this is constant kada, so minus v by u into dh0 by dt. This is constant because the body is moving perpendicular to the principal axis. So v by is constant. But what is dhi by dt? Velocity of the object in, velocity of the image, velocity of the image in y direction. So idantha bodulu enayachu, velocity of the image in y direction. ఇది x direction దాకా వచ్చింది, ఓకేనా? x direction ఇది. సో velocity of the image in y direction is equal to minus v by u into dho by dt అంటే ఏంటి? Velocity of the object in y direction. So vo, velocity vector, vector ఏ direction? Y direction, please. So this is the formula you have to use in second case. అర్థమవుతుందా మీకు? సో వెలాసిటీ ఎందుకంటే ఈ డైరెక్షన్లో మోషన్ లేదు, So you cannot use this formula. You have to use this formula, second case. Because body is going in this direction, perpendicular kabatti, UV constant kabatti, height of the object to height of the image changes. So velocity of the image in y direction is equal to minus v by u into velocity of the object in y direction. Please make a note of this one. Clear? Right. Let us go to the next one. Third case. Let us go to the third case. Third case will observe cheyandi careful ga. Very, very important. Third case is very dangerous. Case 3. Object is moving with some angle. For example, say 2 meters per second. Okay? Towards the mirror. Third case ఏమవుతుంది? Object is moving with some angle. Angle తో మూవ్ అవుతున్నప్పుడు ఏముంటుంది? దీని కాంపోనెంట్స్ ఉంటాయి అప్పుడు 2 cos theta అలాగే 2 sin theta. అంటే ఆబ్జెక్ట్ ఈజ్ మూవింగ్ ఇన్ x డైరెక్షన్ అండ్ ఆల్సో y డైరెక్షన్. x డైరెక్షన్ y డైరెక్షన్. అప్పుడు ఏంటి? x డైరెక్షన్ మూవ్ అవుతుందంటే u is changing, v is changing. Use this formula for x direction. First formula, velocity of the image, okay, with respect to mirror, that is vi minus vm is equal to minus v square by u square into vo minus vm, vectors all are. This is x direction, please, because body is moving in x as well as y direction. So appudu emutundi idi mirror move aithe you can apply the formula like this. This direction positive, this direction negative. If mirror is at rest, you can take this away, 0. So this is the formula you have to adopt. X direction. For y direction, body is also moving in y direction. In the kitchen make formula second case lo that you have to apply. Into the height of the image by height of the object is equal to m, that is equal to minus v by u. And ఏం చేసాం? డెరివేటివ్ కట్టాను కదా. Height of the image is equal to minus v by u into h0. దీని డెరివేటివ్ కట్టాం కదా. dhi by dt is equal to minus v by u into dho by dt. So this is what velocity of the image in y direction is equal to minus v by u, velocity of the object in y direction. So these two formula you have to use and you will be getting in a vector form, x direction or y direction, and use the formula as usual to find the image. V is equal to uf by u minus f. So after getting this, put in these two formulas. So x direction loni y direction lo kuda vachesthundi. Clear? Now let us go to the last case. Last case. See, last case లో ఏమవుతుందో చూడండి ఒకసారి. Last case. Last case. Last case is nothing but very carefully you have to do. Mirror is there, but object ఇక్కడ లేదు. It is above the principal. ఎక్కడెక్కడ ఉంది object at some height. For example, say some 2 centimeters or 3 centimeters. ఇక్కడ ఉండి it is moving parallel like this, like 2 meters per second. Object is not on the principal, it is above at some height. And the initial height of the object is given. And from there it is moving parallel. It is moving parallel. And ఇక్కడ ఏంటవుతుంది? It is moving కాబట్టి u changes, v changes, u change అవుతుంది, v change అవుతుంది. You can use this formula again. Okay? అంతేకాకుండా చూడండి, u చేంజ్ అవుతుంది, v చేంజ్ అవుతుంది కూడా ఈ ఫార్ములా యూజ్ చేస్తారు. ఏది? వెలాసిటీ ఆఫ్ ది ఇమేజ్ ఈజ్ ఈక్వల్ టు మైనస్ v స్క్వేర్ బై u స్క్వేర్ ఇంటూ వెలాసిటీ ఆఫ్ ద ఆబ్జెక్ట్ x డైరెక్షన్. బికాజ్ u ఈజ్ చేంజింగ్, v చేంజింగ్. తర్వాత ఏమవుతుంది? ఇలా మూవ్ అవుతుంది కాబట్టి హైట్ కూడా చేంజ్ అయ్యే అవకాశం ఉంది. సో అప్పుడు ఏం చేస్తారు మీరు? ఇందాక ఈక్వేషన్ ఇచ్చాను కదా, hi బై h0 ఈజ్ ఈక్వల్ టు మైనస్ v బై u. So height of the object to height of the image also changes here. HO, HA also changes. So what I will do is I will find UV derivative. UV derivative in maths. UV derivative ఎలాగంటే చూడండి ఒకసారి, HI into U is equal to minus V into H0. Okay, అంటే ఫస్ట్ దీన్ని తీసుకున్న ఫంక్షన్ derivative of this one du by dt plus U into dH by dt. The same way right side minus V derivative of the second one dH0 by dt plus H0 into minus dV by dt. So this is the function you have to obtain for the fourth one, because ఇక్కడ H0 height of the object అలాగే height of the image రెండు చేంజ్ అవుతాయి ఇక్కడ, because it is moving at certain height. X direction ఫార్ములా యూజ్ చేయాలి, ఇది యూజ్ చేయాలి. సో ఇక్కడ జాగ్రత్తగా గమనించండి, వాట్ ఈస్ HI? height of the object initially. height of the object initially చూడండి HI. height of the object initially 2 centimeters or 3 centimeters, that value. What is du by dt? What is du by dt? Du by dt, velocity of the object in x direction. Velocity of the object in x direction. What is u? Object distance from the pole. Object distance from the pole, of course minus value. And what is dhi by dt? What is dhi by dt? I told you before, velocity of the image in y direction. Identidi velocity of the image in y direction. Velocity of the image in y direction lo image dhi by dt. Next, what is v? What is v? Image ekkada form and image distance, image formation, image right side or left side, image formation, distance. And what is dho by dt, please? What is dho by dt? Velocity of the object, not velocity, velocity of the object in y direction. Velocity of the object in y direction. HO, height of the object initially. This is height of the image. HI is height of the image, please. Object and rasan edi. HI kada height of the image is height of the image. This is height of the object initially. I'll write here. Height of the object initially. And what is dV by dt? V and nt, velocity of the image. Okay? Sorry, what is V? Image distance, image distance. V and nt, image distance. మరి dV by dt అంటే ఏంటి? ఇమేజ్ వెలాసిటీ వచ్చింది కదా మనకి, ఎంత కొంత వచ్చి ఉంటుంది, 8 centimeters per second 5 meter. dV by dt అంటే image velocity. dV by dt means with what velocity image is moving. So when you substitute all these values, then only, because in this case x direction వాడాలి, this UV derivative కూడా వాడాలి. When you substitute all this, then only the fourth problem will be solved. Clear? So in combination of mirrors lo tarvata ee different 4 cases unnai spherical mirrors lo velocity. That is, first case object moving parallel to principal axis. Second case, object moving perpendicular to principal axis. Third case, object is moving at an angle theta. Then x direction, y direction. UV changing, HO and HI, object distance, height of the object and height of the image also changing using UV derivative. The last case, object is moving at certain height from the principal axis. U changing, V changing. And finally, height of the object and height of the image also changes. You have to use this formula. So these 4 conditions are very, very important in the examination, NEET and MCET, and also in advanced levels. In next part of the, this is part 3 of ray optics. In next 4th part, we will try to complete in the next part, that is refraction of light, etc., etc. Okay.